Section 13.1 is going to be about our normal curves and using normal distribution to calculate the probability of events occurring. Normal curves are going to be symmetrical, where you start at the average and then it's evenly distributed as you go left and right around the curve. The normal distributions are when we're going to use our standard deviations to help us figure out the percentage that will be in each part. So this drawing down here, this gives us a normal distribution, and it has some symbols on there that we haven't seen yet. There's an X with a line over it. We call that X bar. That is representing the average value. So whatever they tell you the average is, that's what's going to go in the middle. So that means 50% of the data is to the left and 50% is to the right. Then this other symbol kind of looks like an O with a little tail off of the top. This is a sigma symbol, a Greek letter, and that is going to stand for our standard deviation. So that is the standard amount that we are going to move to the left and to the right. As we go to the right, the values get bigger, so we'll add 1 deviation, 2 deviations, 3 deviations. And as we go to the left, they'll get smaller, so we'll take the average, subtract 1, subtract 2, and then subtract 3 standard deviations. All of these numbers that are pointing to parts of the graph are representing the area underneath that curve. These can be written as decimals. As percentages, but I'm gonna leave everything as decimals because there are a few problems that if you change them to percentages, they're going to give you the wrong answer. So we're just gonna leave them as decimals for now. Okay, and then we are going to be finding the value or probability in between just two terms, and that's something that we're going to go over and do some examples for as well. Here is our vocab, so if you want to pause it and copy down those definitions, you can. So we are going to be doing different types of sampling. Experimental sampling is when you are going to make a change to something and then you are collecting data to see what that change does to the information you gather, whether it has an effect or it does not have an effect on what you are looking at. And then observational sampling, this one you're just observing, you're an observer. So you are going to collect data without making any changes, and then you're going to see if there's any effect on the behavior you're looking at based on the data you collected. So an experimental sampling would be, for example, if I told half the class you have to go to bed at 9 o'clock a night before a test, and then the other half of the class I tell them they have to go to bed at 1 o'clock before the day before the test, and then I compare their test scores. That would be an experimental sampling because I am telling them what time to go to bed, and then I'm collecting data and information. An observational sampling would be if you guys took your test and I asked what time did you go to bed, and then compared your test scores that way. So that's the difference between experimental and observational. Then we have biased sampling and unbiased sampling. For biased sampling, some groups are represented while others are not able to be represented. For example, if I wanted to figure out who the best math teacher in the building was, but I only asked students who were in my class, or only students that were in Mr. Page's class or someone else, that would be biased because I'm only asking students who are in a specific math teacher's class. If I asked who is the best math teacher in the building to all of the students in the school, that would be more unbiased because it's representing everyone in the school. Or if I sampled some students from 9th grade, 10th grade, 11th grade, and 12th grade, so I got a wide range of students that are from different groups, that would be an example of unbiased sampling. Okay, so we're going to use some information, and before I go, I think I forgot to say this in the video. I have it written down, but you do need to have this curve memorized because those values are going to be useful. They will not be given to you on the test. So make sure you have those memorized. Practice writing it down a couple of times, drawing the curve, make sure the numbers are in the same spot. The nice thing is it is symmetrical, so everything that's on the left is the exact same on the right. So you just have to memorize half of it and then repeat that pattern as you go over. Okay, so now our examples. So on the front of your packet, I put 2 sticky notes. One of those sticky notes we are going to use for this example, just so you have enough space to write. So this is my sticky note over here. So on your sticky note, we are going to draw a normal distribution curve. So we are going to put the average line, and then we're going to draw the symmetrical curve on each side. We're going to start in the middle, and then we're going to go 3 deviations to the left, 3 deviations to the right. So we need 3 tick marks on the right and the left. Okay, and if you would like to put dashes all the way up, you can, if that's easier visual for you. I like to put the dash marks because it helps me remember it's the total shaded part in those. And then we're going to fill in the numbers. So the first number in the middle 2 are 0.34. Then the second number going in each direction is 0.135, 0.135. Then, oh, I need to draw my curve a little bit further, sorry. Then my third one on each side is going to be 0.0235. 0.0235. And then the last section, or the last tail, that's what we call them a lot, is 0.0015. So if you need to pause it to finish drawing this on your sticky note, you can. Okay, so we're going to use that for our question number 1, A through E. So for this problem, it says a survey shows that the time spent by shoppers in a supermarket is normally distributed with a mean of 45 minutes and a standard deviation of 12. Those 2 pieces of information are going to be helpful in labeling our picture. So the mean always starts in the middle, that was 45 minutes. And then our standard deviation was 12 minutes. So as we go to the right, we are going to be adding 12. And then as we go to the left, we're going to be subtracting 12. And those are the deviations or the values that we are counting by. So for this one, as we add 12, we would get 57, 69, and then 81. And as we keep subtracting 12, we would have 33, 21, and 9. Okay, so now we're going to use the same sticky note for all of example 1, so we don't have to keep drawing it multiple times. Okay, if you want to use highlighters, I'm going to use a couple different highlighters. For example A, it says what percentage of shoppers at the supermarket will spend between 33 and 57 minutes in the market. So between 33 and 57, that would be these 2 portions in the middle. So to find the percentage that was there, we are going to take 0.34 plus 0.34. That will give us our percentage between those 2 values, which would be 0.68. Now again, you can leave your answer as a decimal, that is okay. Or if you want to change it to a percentage, you can. You have to put the percent symbol behind it though. So those are the 2 possible answers that would be accepted for full credit. All right, our next one, example B. What percentage of the shoppers at a supermarket will spend at most 21 minutes? So at most means they can be there less than 21, but they can't be there more than 21. So we're looking for 21 and less. So I'll find where the 21 is, and I'm looking at the sections that are to the left of that. So that is the 2 sections that are 0.0015 plus 0.0235. When you are adding these together, you are allowed a calculator on this entire test. So If you are worried about adding decimals, that is okay. You can use your calculator. Just be careful with the zeros. It's really easy to lose one, and then that will make your answer way too big or bigger than it should be. Okay, so if we were to add these ones together, I'm going to do it without a calculator really quick. That would be a 0 at the end. 1, 2, 3, 4, 5. And then 2 plus 0 is 2, 0. Okay, so we would get 0.0250. And that would be our probability. Again, if you changed it to a percent, it would be 2.5%. Those are the two options for the answer. All right, our next problem. C, what percentage of the shoppers at the supermarket will spend at least 69 minutes? So if it's at least 69 minutes, that means it's going to be 69 minutes or more, because we're looking, the smallest amount of time they spend there is that 69 minutes. So we'll go 69, and we're looking at the ones that are more than that. So again, it would be those two sections to the right of it. So I'm going to add those two values together again. And you'll notice it's the exact same as the two that were on the left side. So these ones, we are going to add them together, and we would get the same answer of 2.5%, or our decimal answer. Okay. So then example D and E, these ones are slightly different, but we will use the same information from our chart to the right. So you are going to find the probability that 3 randomly selected people are in the supermarket 69 minutes or more. So in the previous 3 problems, we only found the probability that a shopper or one shopper would be found. So that is the first step that we are going to do in the problem where we are selecting more than that. So you are going to find the probability of 1 selected is in that part of the graph, in that section. And then you are going to raise it to the power of the number that you are selecting. Okay, so the probability of one event, you can just add together the sections. For the probability of more than one of the same event occurring, you find the probability of 1, and then you raise it to that power. So these numbers are going to be really, really small. Sometimes they'll be smaller than others. For this one, it's the probability that a person spends, people are in this 69 minutes or more. And if you look, we just found that single probability in example C, which was 0.0250. And we want to find the probability that 3 randomly selected people are there. So we're going to raise this to the power of 3. So you're going to want to grab your calculator. Let me pull that up really quick. Okay, so we had, 0.025. If you want to put the 0 at the end, you can. It won't change your answer. Raised to the power of 3. Okay. Now, if your calculator gives you scientific notation like this, you need to write it in standard form when you write your final answer. Okay. Let's make this smaller. Oops, lost my calculator. Let's type that in one more time. 0.0250 raised to the power of 3. Okay. So there's our answer. And let's make this one smaller so we can see it. Close that. There we go. Okay, so the calculator showed 1.5625 e negative 5. That's not a 5. There we go. So this is scientific notation, and that's telling us we're moving, because it's a negative 5, we're moving this 5 to the left. That's where our decimal point goes. All of these blank spaces get filled with a 0. So that means our final answer, this is not a very big or very likely probability. It's 0.0000156625. That would be our probability of selecting 3 people that are in there 69 minutes or more. Okay, if you want to pause and try the next one on your own, you can. So for the example E, they said find the probability that 4 randomly selected people are in the supermarket at most 33 years. So this time it's at most. So we are looking for 33 years or less. So we have that 33 here and then the or less part. So we're going to add together those 3 end values to find the probability of 1 person being selected in that part. So we would have 0.01015 plus 0.0235 plus 0.135. That's going to give us the probability of 1 person being selected. So we'll add those all together, plus 0.135, to get our probability. And that gives us the probability of 0.1615. And we're selecting 4 people, so we are going to raise that then to the power of 4. And again, this one is in scientific notation, so we have to write it in standard form. So we have to move that decimal 4 to the left, and that would give us 0.0006802. And that's far enough for our answer. Okay, so that is how you would do the first problem on this paper. Oops, it won't let me move now. There we go. Okay. All right, if you have questions on this problem, make sure you are asking, and then the next video we'll go over the last part of the notes.